Hello dear children, how are you all? Hope you all are fine and doing well. Dear children, we are doing the chapter light energy. So far we uploaded 2 videos and this is the last video. I mean to say that today we are going to complete the entire chapter. I mean not in a single video, I mean to say. So with this today's video we are going to finish the light energy chapter. Dear children, in the previous classes we could cover about the reflection concept. I mean to say what is the reflection, laws of reflection, types of reflection, and we have seen even verification of laws of reflection. And in just a second video we discussed about the image formed by plane mirror. Dear children, the characteristics of the image formed by plane mirror is very important. Children, did you remember that? Come on, just let us sit together. I'll be telling, come on, you go on thinking about it. So always plane mirror forms virtual and erect image, and in a what we can say image distance is always equal to object distance, and the image height is always equal to object height, and image is laterally inverted. What does it mean lateral inversion means? Dear children, means whenever you stand in front of a mirror, your left appears as a right, right appears as a left. So that is what actually lateral inversion. And even we have seen what in English alphabets how many letters will show lateral inversion, how many letters do not show lateral inversion. Children, did you remember? Can you guess? If so, pause the video and comment your answer. How many letters will show lateral inversion? Dear children, if I am not wrong, 15 letters. 15 letters will show lateral inversion and remaining 11 letters do not show the lateral inversion. And in the last class, one point we missed. We discussed everything about the mirrors, but we forgot the applications, that is the use of plane mirror. Children, I think see it's very simple. I no need to tell you. Let us just think together, teacher. So what are the applications? What the use of plane mirror? First one, in everyone's house, dressing table will be there. For that, big plane mirror will be there. So plane mirror is used as a dressing table. Even in hospitals, opticians also will use this plane mirrors, and even solar cookers also we can use a plane mirrors. Even in periscopes, in a kaleidoscope also we can use a plane mirrors. And one more place is there. What is that? Yes, that is a barber shop, children. In a barber shop also we can use a plane mirrors. So these are some uses or applications of the plane mirrors. And what is actually then today's agenda? Achha, before that let me tell you. So as I told you that we uploaded the 2 videos so far. The links will be given in the description. Just go through those videos to get a full command, so that in today's class will become very easy and comfortable to you. So in today's class, very simple, we will be talking about the speed of light. What happens when white light is passed through the prism. Then we talk about the primary colors, secondary colors. That's it. There's a very, I think it is going to be a very small session, but it's going to be quite interesting. Dear children, first let us talk about the speed of light. Speed of light. Dear children, this concept now it's very simple, very small only, but in a higher classes it's going to be a very crucial. It will play a crucial role. Speed of light, dear children. See, if I am not in the first class of the light chapter, I told you, as long as the medium is same, light will travel in a straight line path. Then immediately we should get a question that, what is that? If light changes medium, what happens? It won't go in a straight line path. It gets deviated. Why? You know the reason? Because light, I can say, so light will travel with the, same speed in the same medium, but light will travel with the different speeds in different mediums. Not understanding? Let me tell you a small example. Dear children, this is a concrete road. What is that? It is a concrete road. Concrete road, let us say. Okay. Again from here to here, sand road. Okay. Next here completely water is there. Completely water is there. Completely water. Now from here one person is coming. He is going like this. The first situation, second situation, third situation. Now first let us say that he crossed concrete road, entered in sand, then he crossed the sand road and entered water and he crossed also. Now my question is that simple question, Do you think that the person will go with the same speed in these three cases? You tell me, in general you tell me, dear children. So I think obviously no. Yes or no? On a concrete road means normal tar road, yes, he will move faster. In a sand, he will be slow down. In a water, more slow. Because that nature of the road is different. Nature of the road is different. Similarly, in the case of a person, let us say this person is light. This person is light. Now these three are different mediums. Different mediums. Okay. So whenever this light will pass through these different mediums, that light speed also changes. Light speed also changes. Okay. Fine. Now let us see what is the speed of the light in a different mediums, so that you will get a more clarity. Children, this is like it's a simple example. It may not be 100% exactly, but just I think you may get a bit of clarity. Okay, fine. The children, almost in air or vacuum, the speed of the light is same. That is 3 into 10 power 8 meter per second. Oh my God! Which means what? 3 lakhs kilometers per second. Yes, the children. Light will travel 3 lakhs kilometers in 1 second. Can you imagine? Okay, fine. Whereas in water, light will travel with a 2.25 into 10 power 8 meter per second. Whereas in a glass, light travels with a 2 into 10 power 8 meter per second. Okay. Whereas in a diamond approximately I am talking, the speed of the light is 1.42 into 10 power 8 meter per second. So in which medium light is traveling with the highest speed out of these four? Yes, not out of these four ma. Light will travel faster in air only compared to any other medium. In any other medium, compared to any other medium, light will travel fastest either in air or vacuum. That is with a 3 lakhs kilometer per second. That is a 3 into 10 power 8 meter per second. Means what? Light will travel faster in vacuum. In a water, when light enters from air to water, it will become slow down. Water to glass, more slow. Glass to diamond, more slow. Try to understand. Now look at here. For suppose, dear children, here is, look at here. Now you should understand very some interesting thing. Let us do. This is air. Here is water. Air, water. Now here is water, glass. Okay, that's good. Now this is glass, diamond. Glass. Now the thing is that when light will enter from, light will enter from air to water. Children, speed means generally will represent with a V, letter V. Okay, now try to understand, whenever light will move from air to water, speed decreases. Whereas from water to air, speed increases. Same thing happens here also. When light will move from water to glass, speed decreases. Glass to water means speed increases. When light will move from glass to diamond, speed decreases. Diamond to glass, speed increases. So dear children, this is the story about the speed of the light. So of course, so much of depth is their concept, but for us, for this class 7th standard, it is not required. Okay, fine. Now dear children, what happens? Can I erase this? Yes. What happens when white light is passed through the prism? When white light is passed through the prism, let us say that. So let us say here is a prism. Prism is, it is like a two-dimensional diagram. I can say it's the principal section of the prism. So it is the principal. Let us say it is A, B, C. The children, now like this, sunlight is coming. Sunlight is nothing but what, the children? White light. The children, if there was no prism, what would happen? Light would have traveled in a straight line path. But when you send this white light to the prism, what would happen? You know, look at this. This is what actually happens. देखा है पहली बार students का आंखों में प्यार. Okay, yes. Now look at here. So here is violet color, and here is a red color. So remaining colors 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's a violet indigo, VIBGYOR. So which means what? When white light is passed through the prism, dear children, it gets split into 7 colors. Which are colors? Violet, indigo, blue, green, yellow, orange, red. You know the reason? Because different colors will travel with the different speeds. Different. Achha, this is like a spectrum. This only we can call it the spectrum. This is a spectrum. But you may get one doubt, sir. Can we see this kind of spectrum naturally? Of course, we can see. What is that natural spectrum? Rainbow, 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 rainbow. Rainbow, rainbow. Rainbow is like this natural spectrum, right? So how this rainbow is formed, you know? After rain, just when it's a slight drizzling, like a tiny water particles must be there. And one important condition, dear children, for suppose here, if a person is like this, okay na? So this is front side, I think. First, if I draw like this, you can't, which is a front, okay, let us say this is front, okay. Let us say please, person is standing like this, but try to understand, okay na? And from behind, sunlight should come. Behind, sunlight should come and water droplet should come like this. Okay, so light should come from behind. And here means you make it one. So here's a prism is there, it gets split, it splits a light, you can say. But you know, yes, in atmosphere, tiny water droplets will be there. The tiny water droplets only behaves like a prism and they will split the light. As a result, we will get a rainbow. As a result, see, to see the rainbow, the sunlight should come from behind. That's very important to us. Okay, as we are seeing many colors, here the word which we got, COLOUR, color. Teacher, what does this color mean? What is a color? What does it mean? How can you define color? Color means color, red color. Yes, many of us will think that color, sir, I know. Tell the definition, come on. Tell the definition. This is very important, teacher. So color is, you know, very important. Light with fixed wavelength, or frequency. So regarding this wavelength and everything, we'll discuss in a higher classes. Okay na? But this is actually standard definition ma. Light with a fixed means, but light should have only one wavelength. If it has more than one wavelength, you know, it is not a color. It is not a color. Now let me tell you technically, you know, day to day we use, hey, I have white color shirt, white color socks, white color anything, white color t-shirt. But you know one thing, I'll give you a surprise. What is that? White is not a color. What? What is this? Sir, how can you see that, sir? Daily we use white color. We use, but technically white is not a color. Try to understand. Why, you know, color means should have only one wavelength. Every color has one wavelength. Every color has one wavelength. But these all colors got mixed to give white. Means in a white light, how many colors are there? 7 colors are there. It is not a single color. White is a combination of 7 colors. White is a combination of 7 wavelengths. So it is not a color. Color means only one wavelength. Red color I can say because it has only one wavelength. It has only fixed wavelength. But white light means its wavelength spreads from violet to red color. So white is not a color technically. Then you make it a one doubt. Sir, then can we say at least black color? If you want to say okay, I don't mind, but technically black is not color. Again, my God, sir, what is this? How can you say like that? Yes. Now in your premises, try to see any hole. For example, electric holders will be there. That holes, how they are appearing? Tell me. Black only, no? Yes, sir, black only. Any hole is there, you can say. Any hole appears like a black only. Do that somebody painted with a black color or something? No. But still, why they are appearing in black now? Because light is entering and light is not coming from that. Light is not getting reflected. Which means what? Absence of light creates black. Color means light should be there, but black means absence of light. So technically white and black are not a colors. Technical I'm telling. Okay, dear children. So this is about a color definition. And here we are going to talk about primary colors and secondary colors. Primary. So first group is a primary colors. So the children here, red, green, blue, red, green, blue. These three are called primary colors. Why are we calling these three are primary colors? Let me tell you only one reason. By mixing these three colors in a proper portion, you will get a white light. I am not saying white color, I don't say. White light we will get, white light. By mixing these three properly, white light will get it. And even by mixing out of these three, any two colors, you can get any other colors. If you want yellow, if you want pink, magenta, any color you will get it. But by using any other two colors, you cannot produce either red or green or blue. Exact reddish you may, bluish, greenish, no. That you may produce, but exact green, exact blue, exact red, I am talking technically, you cannot produce. That's what we can call these colors as a primary colors. Now let us see secondary colors. Let us see secondary colors, and we will see some example how can we add these three colors so that to get a secondary colors. Secondary colors. Now look at here now. Let us say here is one color, here is two colors, here is, okay, look at here, this is red, okay, this is green, okay, this is blue. When red, green if you can add, you will get yellow. Red, blue if you can add, you will get magenta, that is a pink color. Green, blue if you add, you will get a cyan color. Very simple it is. Try to understand. See, if you mix red plus green, so let me write here. So children here, red plus green, red plus green if you can add proper portion, you will get yellow color. So yellow is a secondary color. And here red plus blue, red plus blue, so you will get magenta color. What is that, children? So you will get a magenta color. Magenta color. Next here green plus blue, am I right? Let me check. Green plus blue, you will get cyan color. Cyan color. This is simply, it's a pink also. Pink. So yellow, pink, cyan, these all are secondary colors. Secondary colors which are produced from the primary colors. But primary colors you cannot produce from any other by mixing of any other two colors. Okay, clear, fine. And here one more important point. It's like what happens when light falls on opaque bodies. See, in the first class only we discussed about the transparent transparent medium, translucent medium, and what we can say opaque one also. Here the children, the very important thing is that here, let us say here one body is there, one body. Let us say here is one more body. The children, this body, if light is falling on it, but what are the light which is falling on this body, if it reflects entire light back, then it appears white. It appears white. Means complete reflecting this. Complete reflecting. It won't absorb the light. That's what the children, during the summer we are suggested to wear the white cloths or at least light colors. Mostly white cloth. Why white cloth? Because white cloth is not a good absorber. It won't absorb the light. If sunlight is falling on your body, on that white color shaded t-shirt, it gets reflected. Okay, na? That is actually the reason behind that, why we are suggested to wear the white clothes or at least light clothes, not dark. And here, if any light, if for example light is falling on a body and complete light is absorbed, such a body appears black. Black means black light, black body is a good absorber, white body is a good reflector. That's what in a winter season we are suggested to wear black cloths or dark cloths, so that we need some kind of heat because it's very cold, right? So if you can wear the black cloths, black cloth will absorb the light which is falling on it. Okay, na? So which body appears actually white, ma? The body which is reflecting the light which is falling on it completely. If all colors are getting reflected from a particular body, that body appears black. If all light, if all colors are absorbed by the body, then that body appears as a black. Now, for suppose here one body is there, ma, and we only can see the 7 colors. For example, on this body, sunlight is falling. Okay, now. But this body absorbed V, I, B, G, Y, O. Absorbed all colors, but reflecting only red color. Then this body appears red color. Try to understand. If any object is appearing red color, means it absorbs all colors except red color. If any object is appearing a blue color, which means what? That object is absorbing all colors and it reflects blue color. If any object is appearing green color, which means what? It is absorbing all colors, it only reflects a green color. So this is how actually bodies are appearing. Body colors are appearing. If any object is appearing a particular color, which means what? That particular body absorbing all color except the color in which it is appearing. Hope it is clear. Fine. So dear children, so with this we completed our chapter. I think it might be a bit of small session, but quite interesting topics which we discussed. Okay, and these topics again you will be learning in class 10th. Of course, in class 8th also little bit touch is there, but in 10th you will be learning in detail. Okay, children. So as we have completed this one and we have to end the session, right? Yes. So dear children, I am telling you this entire light energy chapter we made as 3 parts. Previously we uploaded 2 videos. The links will be given in the description. Just go through those videos. Okay, dear children. Thank you so much. All the very best.